So what I want to talk about today is really a little bit of our journey at scaling out data science, both in terms of technology, but I would say more in terms of what it takes to scale data science in a large organization. And so some of my experiences, some of the lessons that we've learned is what I would like to share. So before we get started, let me talk about a situation and an actual event that happened. It was fall of 2016. It's a little less than a year ago. I was in a board meeting and we were talking about various things. One of the topics was data science capabilities at Target and the advancements we made and the impact we made to the business. So one of the board member, and by the way, this is very common in board meetings, you do well, they will ask you to do more. And what they said is like, what new thing can you do with data science given that the holiday season is around the corner? And by the way, we want it to be impactful and something new. So of course, in the room, I'm very excited. I raise my hand and I say, yes, we'll get back. So I started thinking, what can we do? And this is interesting because signing up for challenge is good, but you don't know what tools you have and what you can affect. So I started thinking about, well, we just finished creating this new EdTech engine internally, and we developed this because we knew that we could extend the science and the technology to make it more relevant than other vendor tools we had been using. We call it Dandelion, and what it does is that takes in a lot of different inputs, user signals, works in real time, at scale, developed with some of the more modern technologies, Spark and Scala, and really capable of delivering what Target requires, which is we have millions of people coming in, and so it's configured so that it can sustain that kind of traffic. And I said, great, so we have this engine and machine, but we also need some content. And so I've been scratching my head, and somebody in my group reminded me that not too long ago, Target had just released an exclusive music album with Garth Brooks. And I said, wow, if we could use this content which was exclusive to Target, and then we have this engine to try to figure out how we can find people who would be interested in this content. And so we started racing. So of course, now it is October and we don't have very much time. So we said, well, let's try to figure out what we can do. So size up the problem. So we figured that we have about 24 million guests, and we call our customers guests, who are potential audiences for this content. In other words, they would be interested in purchasing this music. And when you purchase music, you're also interacting with Target in other means. So it's not just this music purchase that we are interested in. And then we were also able to figure out that if we use our new technology, it is likely going to be 7x better at identifying and converting. And so we said, this sounds good. And we said, well, let's look at the segment of guests. And they were also some of our best customers because they spent 26% more online. And so we said, this is all the things coming together to answer this challenge. And so we identified a budget of 50 million impressions. It sounds like a lot, but in the world of ad tech, 50 million can be consumed within a few days. And so for whatever set of reasons, we got the budget. We had to use it judiciously over a few weeks, somewhere between 3 to 4 weeks, and find out and report back what we did. And so, of course, we did it. What we found was we were able to get 3x the CTR than what we had found elsewhere. So in other words, we found this campaign, we were able to get 3x results, all due to big data and technology. Imagine the excitement that me and my team had. Like, we thought we'd conquered the world, we were going to go out and just deploy this engine all over the place. Well, it's been 7 months, and let me tell you, the machine has, the EdTech engine, Dandelion, has expanded, but it has not conquered the world at Target. And I'm sure you have faced this situation many times before. Thankfully for each one of these stories, we have many more that are successful, which gives us a little bit of a corpus as data scientists of positive labels and negative labels so that we can learn, but it's a little bit more of human learning, so not very much experimentation. So before we jump into that, I wanted to give a brief background on Target and our journey because it is important to set the context. So Target, like other retailers, is trying to change and adopt to what is happening in the retail industry. This is a picture of one of our newer stores. So we're trying to branch out and experiment with smaller format stores. This store is based out of Silicon Valley, where I am based, and some of my teams are based too. So let's think about the scale and complexity of data at Target. You can probably read all of this, but there are a lot of things that stand out. And that was the reason why I joined Target. I said, this is an amazing playing field where you have all this data and it is available, accessible, and ready to be decisioned upon. Right? So 1,800 stores, a very vibrant e-commerce site, $70 billion in sale, 1 million products, 80 million guests. We have 3 to 4 million unique visitors to our website every day, 300,000 employees. It's a lot of data. And I hadn't even thought about all the other data that we were collecting. So we have 5,000 trucks. It's actually more than that, which ships about 5 billion packages every year, right? So every step in the process is an opportunity to collect data, to record data. As it comes and flows through our supply chain beyond trucks into buildings, it's just a lot of data being collected. And we are not done. We have sensors, we have electricity meters, lots of different things. And of course, I have barely touched upon video and audio data through our call centers and video cameras that we have. In short, lots of data, lots of complex data at Target. And the challenge is, how do we convert this potential into something that becomes really useful for Target as an asset? And so we realized that in order to do this, we formed a separate group. So I have the privilege of leading this group. So I'm very happy about that. But in short, wrong button. In 3 short years, we've been building out this team. We've recruited almost 90% of 150 data scientists and data engineers in the last 3 years. So scaling the team, scaling the infrastructure, but more importantly, deploying the solutions in multiple domains. So let me explain what we mean by domain. At Target, we have responsibility for bringing data science in all aspects of business. So a domain is doing personalization on the website. Another domain is marketing, written large for all the marketing that we do, supply chain, inventory planning, transportation planning, and optimization. If you think about stores and labor planning, labor scheduling, information security, HR planning, there are lots of areas, and we've been able to deploy these kinds of solutions, some more successfully, some less successfully, across the board. And of course, we can't do it unless we have good modern capabilities. So I can assure you, we do all of the modern things that people here at KDD come to learn and do. So deep learning, yes, we do that. Stochastic optimization, yes, we do that. We have our own clusters. We know how to deal with GPUs, CPUs, and in fact, some new technologies that we've invented. But I'm probably not going to talk much about that. I'm going to focus on people and problem definition. Now, you might be wondering, why people? Well, we're learning what it takes to make data science scale out and successful in large organizations, and I'm sure each one of you are trying to do something like this. So let me start first on the people side, and then I will quickly touch upon the problem side. But let me say this, it's many times a data scientist, and I've done this many times, we are interested in the cool new algorithm, right? Like everybody wants to go do GPU computations, the latest CNN algorithm. But we forget what our users want, right? Our users may not care about our fancy algorithms and math. And so that brings into the people aspect. We will talk about some of the mathematical aspects too, but first, people. So what we've learned the hard way is unless you build trust and credibility with your intended users, you're not going to be successful. And many examples come to my mind, but we were just having this conversation earlier that somebody was unable to get their bags. Let's leave it aside, but of course there was an algorithm at play, and who are we going to blame? We are going to blame the poor guys who are actually putting away the bags and that they didn't do their jobs. That is what happens. When you go to your users, you go away, you walk away after deploying your algorithm, and if it fails, they need to clear up that mess. And they need to know that you're going to be there with them to understand that mess, to clear that up, help them and augment their capability of spotting that you're going to get into a messy situation. So remember, Make your users successful first. The second thing has to do more with change management, right? We are trying to change how people operate. And remember, these people have been doing things, in our case, if you think about stores or supply chain trucks, for decades many times, and they've learned a lot of things, right? Like we can never undermine the value of human intelligence. And if they get a negative experience when you're convincing them to go down a path that they feel very uncomfortable with, they are going to reject your algorithms, no matter how good they are, right? Which is something that happened with our Dandelion engine. The algorithm was fine. There were nuances that we did not understand. For example, the way that you set up campaign, there are many dependencies in terms of how you set up creatives, how campaigns are run, what are the financial incentives. Unless we understand that, the engine itself is not going to make it successful. Second one that we have stumbled upon in last 3 years is shared understanding. And honestly, when you talk in a meeting and you think both sides agree, that's not shared understanding. You need to end up to a place where you have a jointly identified problem statement. We've converted this into quarterly objectives and key results that some of you are familiar with, if not just Google up OKRs. But really, you have to act as one team, and no better way than you're aligned at the eventual goal. Again, understand the problem you're trying to solve. It is not the algorithm. Algorithm is a means to solving the problem. And last but not least, don't underestimate the value of user engagement. Your goal is really to convert the users to use better tools and technologies. And you want to do that because it helps make their life easier. I can tell you a personal anecdote where we tried to deploy a fairly sophisticated and very effective algorithms, except the users needed to spend 3 times as much time as doing it the normal way. So yes, the benefits were great, but the 3x increase in your workload just killed that product. Thankfully, that was more than 10 years ago, so I've smartened up a bit. So before we go into the other aspect, which is now, yes, we're done with people, not completely, but really, how do you want to use the analytical machinery for solving these problems? So let me tell you about what we need to do. So this is about assortment planning. So Target needs to decide every season, every year, what products are we going to carry, when are we going to carry them, how many, where, lots of interesting things. And we launched this brand, Cat and Jack, for kids' clothing about a year and a quarter ago, or a year and a half ago. And so we needed to plan this assortment. What styles, what colors do we carry, where do we carry them? And it's a very interesting data science problem because, as I mentioned, this itself, if you look at various combinations, we carry usually thousands of styles compared or crossed with at least tens of colors, crossed with tens of sizes, crossed with 2,000 locations. You get a very large optimization problem. And this is just the optimization part. I'm not even talking about the demand forecasting and did we get the colors and sizes right. So interesting problem. We got started. We got working on it. It took us more than a year to get to a successful launch of one category through assortment optimization. And I will talk about what we learned because the next 6 launches just took us 3 months. And let me tell you, data or data science was not the bottleneck. It sounds unusual, but that is true. So I'm going to talk about a few things that we need to do in terms of analytical support. The first thing is really we need to create analytical support tools, and I will talk more about these, why they are important. Testing and measurement, and many of you have known about testing and measurement and even A/B testing, but the real crux of the matter is that we frequently talk about correlation versus causation. What you're trying to do with testing and measurement is to make sure that you're not confusing correlation for causation, because at the end of the day, what you need to deliver are better results, not an A/B test that works, and then find out 3 years later or 3 months later that it was correlation that you were chasing and not causation. And the last one is really bringing in engineering and software development mindset. Agile and product development, I'm sure many of you are familiar, but there is a little bit of a twist of what it means to apply this in a research discipline. So let's look at this image, right? Like imagine that you have a brand new car. It's a fancy car with a lot of new features. But one of the features is that it just has a steering wheel, right? The dashboard is completely empty. You have no gauges. Imagine if I ask you to drive that car. You'll take it for a spin, but would you really use it for a long-distance journey or even commuting to work? Because you know what? You have no idea when you'll run out of fuel. You have no idea whether you're traveling at the speed limit, under the speed limit, over the speed limit. This is what happens when we take algorithms to our end users. We give them a car with a dashboard with nothing on it. So what we have learned, and you saw a little bit of that in the previous slide, is you want to give some additional information to the users, and you want to do it for multiple different reasons. So the first thing you need to provide is give them an alternative set of solutions so that they understand what trade-offs the machine is making, right? Because sometimes if you think about GPS, you may not want to take the fastest route because if I'm traveling to Canada and if I'm going to travel on toll roads, I don't know how to pay for tolls. I would much rather avoid tolls. So you have to understand those scenarios. But there is another important reason why you have to augment that with what I call simulation scenarios. As humans, everybody, whether you like it or not, are trying to create mental models and understand your fancy models. You cannot take to them a mathematical equation or a complex graph and convince them that this is why it is going to work. So what do humans do? They try to ask the questions for which they know the answers. And they are going to use that to get comfortable with the machinery. So if it's a GPS system, what you're going to do is you're going to ask for a route that you take every day to work. And then you're going to see, well, does it give me back the route that I'm used to? Then they're building that confidence. Our job is to make sure that we make it easy for the users to build confidence in our solutions so that they adopt the solutions rather than they are turned away. The last one are decision levers, right? So even in the car, and of course we can create, or we are at the brink of creating completely self-driven cars. But I would imagine that you still want a steering wheel or at least a couple of controls in there so that you can override it. So it is important to know what decisions you want to leave with the users and when and how to use them. In other words, shooting for 100% automation is not going to make you successful because, believe me, our models have a long way to go before they can understand the reality well enough. So acknowledge and accept that. Let me explain how this plays out with our assortment planning stuff. So it took us a year because there were certain things that we did not realize. One of the things we didn't realize is that we have this must-have items that we carry in our assortment. And these are items, and I'm sure you will identify with that. It's a particular flavor of potato chips. And if you don't see it in the store, you're going to be upset. So upset that you might not come back to the store again. And that happens. We can quantify it. We can tell you what is the rate of loss for each of these items. And clearly, not everybody wants this potato chips. But for someone, it's a potato chip. For somebody else, it's a deodorant stick. For somebody else, it's a specific cookie. Lots of different things. And so what we learned over time is that the merchants who were charged with creating this assortment were really apprehensive because we hadn't taken into account this effect. Because we were creating these models that were aggregate models that were telling us how the sales were going to move, really a perfect scenario of correlation analysis. And then once we started understanding this and started incorporating this at the guest level, saying, for each bag of potato chips, if we were to not carry it, how many people are we going to really piss off? Or if we were to add it, how many more people are we going to attract? That allowed them to understand and accept the assortment optimization solution. But that is not enough. So I will talk a little bit more about these themes. So I mentioned testing and measurement. We talked about how we can confuse correlation with causation. But an important thing that we have started tracking is user impact metrics. What I mean by that is that you've deployed an algorithm or system. Are you seeing how frequently users are engaging with it? But more importantly, has it made their work any easier? Right? So if it used to take them 2 weeks to plan an assortment, is it now taking them 1 week or 1 day? Or is it taking them 4 weeks? Not because of the tool, but you've basically created a process that is more complex than before. So please pay attention to user metrics. Key supporting metrics, remember the example for must-have SKUs? That was a new thing and that we needed to provide because The algorithm usually has a single objective function. It does not know about all the other things that are also at play, right? So when somebody, for example, in a store is helping with the store floor, not only are they trying to make things work, but they're also trying to optimize their own schedule, right? They need to go pick up their kids. And so there are things that we don't see and we don't take into account. And so you have to provide that additional context. I do have an example to talk about. And the last one is I always worry about, did I get the model right? So it is about continuously having hypothesis, not to support your intuition, but to make sure that your intuition is not wrong, right? What I mean by that is that you may find evidence to say that if you were to take some action, it will have the desired outcome. What you should ask is that, what are other ways in which I might get the same outcome without having taken that action? That will help you improve your models, right? Because we want our models to get smarter, not just correlate data better. So here is an actual screenshot. This is an application we use for promotion planning. And really the objective is, as merchants, we need to figure out what promotions we are going to run. And this is after the assortment process has completed. And so what you see in first couple of columns is really metadata information around what promotions you are planning, how many items do we have, when do we plan to run the promotion. Then we start getting into metrics, and some of the metrics would make sense. We are in the business of retail, so we want to know how many units we are going to sell, how much money we are going to make. But then, if you think about it, if you're going to buy 2 packs of Crest toothpaste, you use them once every 3 months because it was on promotion, and not make any purchase for another 6 months, that is a wash, right? So we made the sale a little bit earlier, but really didn't help in terms of improving our business, which is growing the business. And so we realized that we needed to create an additional metric, which wasn't part of the model. The model is just trying to optimize the response, which are incremental revenues. And incremental promotional revenues have a number of different components that we need to carefully take into account. That has become a data science problem in itself. And that is what you see in the highlighted column, the middle column. But what we learned is that data science and data does not carry all the information. So imagine you were trying to run a promotion on a new cookie that you've never promoted. Like, of course, your price elasticity is going to be very, very unreliable. And trying to recommend a promotion based upon some spurious information is not going to be helpful. So we've created this confidence flags that you see on the right. And again, this is to help the users go through their tasks easier. If it's green, you don't need to worry about it. If it's red, we are screaming and saying, please look at it. We don't know. Here is a recommendation. Please change it. Over time, we think data science will make most of these red blocks go away. Maybe we'll still remain with 10%, 15% of them because there is a part which is aesthetic and art, which the algorithms may not be able to conquer yet, or at least in the next couple of years. That leads me to the last section here, which is really bringing the agile and product mindset. And many times what I've done is that you wait for the algorithm to become perfect, and then you think about where you're going to deploy it. What I would say is think about deploying your algorithm at the earliest in the operational or execution system. In fact, we have a term or a phrase for it. Somebody on our team came up with it. He calls it build the world's worst model first, because you want to deploy it in an execution system so that you can start testing it end to end. Then you can start improving it. And really, agile mindset is that instead of going from a skateboard to a car directly, you at least want to go through intermediate steps. Many times you don't know what you're going to end up with, which is why that methodology is a little bit more robust. So if you know you want to make a car, perhaps you can make a case that you want to go a different route. But frequently, our end result is not very clear. And so having a mindset of continuous and iterative development and deployment is important. All of our algorithms are deployed almost on a weekly or bi-weekly cadence. And that's the only way we can make rapid progress. For example, our personalization engine has improved its performance by almost 2x in the last 3 years over a comparable baseline. And that's because we can continuously make improvements, not wait for the big bang. By the way, you also lose precious time and user mindset doing that. The second one is champion challenger. It's, again, we talked about hypothesis testing, but you should think about creating an ecosystem where each of your algorithm is being actively competed with a variety of other algorithms. And you want to make it almost automated and continuous so that people can come in, think about Kaggle done internally so that each algorithm is forever competing with other algorithms, and it will stay on its perch as long as it performs well. And you can not do that unless you have both the engineering discipline and the continuous development mindset. Last but not the least, all of us interact with these complex machines through user interfaces. And please pay attention to that. Just like how Apple changed the game with iPhone, we need to create better interfaces so that our algorithms can be controlled and interfaced with much more easily than what we do today. If the only way to interact with the algorithm is to upload some complex file of configurations, that is not a workable solution. So where does this lead us or leave us? It's, again, as data scientists, we are trying to find patterns. We are trying to create templates of how we do work. And we do need this because when you have almost 900 people, 150 data scientists working on dozens of products, we need a scalable and repeatable process. So we've talked a lot about users, so I won't go there. But problems and outcomes are important. We talked about joint problem definition. But defining outcomes and measurable outcomes is important. You want to know whether you've succeeded or not. And it also helps you clarify what problem you're solving for, right? You might be solving for some kind of detection, but the users might be solving for containing certain condition. Detection is different than containing the condition. Decisions are important. We need to know as algorithms developers what decisions we are going to make in the algorithms and be very explicit about it, because there are some things for which we do not have the luxury or ability to make changes. A simple example is we can come up with a great assortment and then we try to put it in a new store that we are coming up with, which is much smaller. There is no shelf space. Again, imagine the condition of the store operator who's going to have all this extra inventory. Where are they going to put it? This is where constraints come into the picture. So you want constraints to make sure that you are taking into account physical constraints, business constraints, or even your strategy. For example, if you're going to launch a new brand, we are going to index towards scaling that brand, even if you don't have any sales history. And then finally, data. You need to pay attention because many times data does not exist or it is collected at the wrong point, does not have the meaning that you want. And so when you combine this, you will come up with what is feasible versus what you aspire to do. And then lastly, I call it DevOps discipline, but this is really the engineering discipline. Your algorithms are not worthwhile if they just stay in a research phase or as a prototype. You need to think about developing and deploying them at scale from day one. This is how we do all of our algorithmic development. All data scientists need to create algorithms that are going to scale for our size and our needs from day one. It can be the world's worst model, but they need to think about scale. So what is my message or takeaway? We are in an exciting time. We think data science is going to change mankind tremendously, and we are at the brink of bringing that change to the mankind. Great. But in order to bring that change, we need to bring change to ourselves to really accelerate that change and affect that change. So I've focused more on the human aspects. Hopefully that resonates with a lot of you, but help us make data science more successful by changing yourself to making it much more acceptable and accepting in the broader community. Thank you.